Well, good afternoon. My name is Mike Snelly, and I'll help serve as co-moderator today for the latest installment of the Shackelford webinar series. If you're new to this series, this is our 11th webinar today, 11 of 12. We'll finish up next month. But the good news is we have a whole series set up for you for 2022. So watch your email. Those will be coming out as announcements in the next 7 to 10 days. Also, if you're new to the webinar series, we ask you to hold your questions, actually put them in the chat feature, and our speaker will address each and every one of those towards the end of his lecture today. I'd be remiss if I didn't again thank Charles Shackelford and Linda Shackelford, former co-owners of TLC Oklahoma City, for their generosity in underwriting this series. You may recall Charles and Linda were co-owners of TLC Oklahoma City for a number of decades, and regularly were able to enjoy being in the top 100 retailers in the country. That's quite a feat if you think about how large the United States is. And the exciting part for me is the current management has continued that legacy of excellence, and also are managing to stay in the top 100 retailers in the U.S. So congratulations to the current owners and management of TLC. And speaking of that, the general manager, Bob Gertis of TLC Oklahoma City, will be our next and last speaker for 2021. And again, stay tuned for 2022 announcements. They'll be forthcoming in just a few days. I'd also like to welcome aboard in advance another member of the team, particularly starting next January, if not next month, would be Stephen Schwerk. Stephen is a landscape architect graduate from our department, and now has decided to pursue his Master's of Science in Ornamental Horticulture, working with me over the next 2 years. So really excited to have Stephen aboard, and definitely excited to have some help with this series as we launch the next 12, starting in January of next year. So let me jump into our speaker today. I'd like to welcome Dr. John Griffiths Jr. from Florida Gulf Coast University, Fort Myers. And John holds a professorship, or professor and chair of the Bernese and Sidney Davis Chair for Horticulture, Education and Research. John is also the current president of the Florida State Horticulture Society. And what I'm most excited about John, I've known him now for many, many years. I met him at University of Hawaii, Manoa Valley a long time ago. And John just continues to do a lot of neat projects overseas. In fact, I think he's working virtually this week as we speak with East Timor folks. But Dr. Griffiths has worked throughout Africa. He's also worked in Nepal. He's worked elsewhere. And he not only well-versed in ornamentals, but also has worked with projects with peppers, with banana, tissue culture, and many other crops. So very excited to have him aboard today. And so really, without any further ado, I'd like to welcome Dr. John Griffiths Jr. John, take it away, please.
All right. Thanks, Mike. I appreciate it. And hello to everyone. So when Mike asked me to talk about this, I think he assumed I would talk about something international. But I said, no, let's talk about something that might relate to what a lot of people encounter on a daily basis. And so I have a number of undergraduate students, and we cooperate with students at another institution here, Florida Southern College, where I used to teach many years ago. And we do a lot of training and research design to try to help students understand how to set up and design experiments using a greenhouse. And so anyway, that kind of leads me to this. So let me go ahead and see if I can share the screen for you. And so there we go. So, so today I'd like to talk a little bit about updated methods to improve what you're doing with controlled release fertilizer. We've done these tests in ornamental crops. There is a fair amount of research actually out from the University of California with empty pots. No, I mean, with no plants. They've done a lot of fertilizer research looking at how fertilizer releases in pots, both in greenhouses and containerized nurseries, but without plants. And so they often say, well, someone else needs to look at the plant part. So that's kind of what we do. So here we go. So what is controlled release fertilizer? And there's lots of definitions. The easiest one, it's a fertilizer that contains plant nutrients in a form which delays the availability of the plant. And so the plant can't uptake it all at once. And so this is the contrast to when you put fertilizer in the water and then all of that's available to the plant just as soon as you pour the water in the pot. So this is the other side of it. And initially, nitrogen was the main control because it was the main concern. And this was developed a long time ago of connecting urea with formaldehyde, and some slow release fertilizers still use that technique. So just because it was designed a long time ago doesn't mean it doesn't work. And these things became commercialized in various forms after the war. And so some of you may be aware that during World War II, nitrate fertilizer was in fairly short supply only because nitrates were used in explosives. And we occasionally hear about people's fertilizer blowing up. Well, nitrates are explosive. But anyway, in the 50s, there was a big move to commercialize this so that everyone wasn't just pouring all their fertilizer in the pot and watching it disappear. And the most common one been sulfur-coated urea, but there's been lots of other innovations. So basically, the concept between these is that either the fertilizer is not immediately available and it becomes available to the plants, or the various nutrients are actually released in small quantities over a period of time. And there's a whole bunch of different mechanisms for how this works. The three that I've shown here in this picture don't work the same way, even though they seem similar. Anyway, there's ways of doing this. There's semi-permeable coatings and proteins and sulfur and plastics and concrete and paraffin and all kinds of innovations on how to basically contain fertilizer and then release it. And so that's what's happening there. So there's a lot of graphics. How does it work? And so I like this one because this is pretty demonstrative of the standard model. So we have a granules, someone call it a prill, there's different terms, but a granule of essentially solid fertilizer, and it's usually nitrogen and of course calcium, phosphates, various things that could be in here, potassium, magnesium, just different salts. And these have been coated with something. And so water passes through the coat, and it basically begins to dissolve the fertilizer inside. It makes a very concentrated fertilizer. And using some fairly standard practices in chemicals, which means if there's a lot of chemicals on one side and not so much in the other of a membrane, then the slip moves. The fertilizer moves out, and it may do slowly or quickly, depending on the design. So there's others, and sometimes we do micronutrients. Sometimes we have things that are not very soluble, so they will dissolve slowly, and we've got these coatings, and sometimes they're embedded in things, and there's lots of things done this way. Polymer coated urea is kind of the same way. So basically, we have our urea inside a pellet, and water moves in through the coating, and then the inside dissolves, and then it moves out. Okay, so there's lots of graphics this way, and it can be nitrogen, it can be anything. So they all kind of work on a similar basis, but not always the same way. So anyway, we're kind of lucky. There's a very comprehensive review on controlled release fertilizer. We get one every several years, but this is the newest one that came out this year. And basically, this tells us a whole bunch. Most of us aren't mathematical modelers, so some people, have theoretically how does it release, and then we can compare that to other things. So the coating techniques, some are chemical coatings, some are physical coatings, various things. The coating materials, as we pointed out before, all sorts of things. There's organic materials, polymers, plastics, concretes, just all sorts of things that have been used. So the important thing here off to the side, the release profile, and that seems kind of not obvious, but the fertilizer releases out of these really in one of two ways. So the sigmoid is an S-shaped curve. So the fertilizer is slow to release, like the bottom of an S. Then it releases fairly quickly for a period of time, so like the center of an S, and then it slows down as it finishes at the top. And that's compared to one that's rather more of a linear thing. It's called a reverse L, but basically we'll see fertilizer release a little bit and then all in a rather linear fashion. And so it just releases kind of at the same rate. And of course, there are others that don't follow quite either one of those. So, so the summary. So let's look at it again. So most CRF granules have a core of nutrients surrounded by some type of coating. And the coating controls how the nutrients are released. The nutrients inside are generally solid, but not always, and they're dissolved when water passes through the coating. And then the nutrients pass out through the coating and become available. And that's sort of simplistic, but it's also just about right. So that would be a good way to explain what you're expecting, keeping in mind that there are examples of more complicated things. So what would we include here? So some important things to think of: surface contact of the fertilizer with irrigation water. So are the control release fertilizer granules just dropped on the top of the medium? And if they are, that would have a different relationship with water compared to whether the granules are stirred into the pot and constantly exposed to moisture in the soil. Now, the ones on the top are going to be exposed to humidity, so there's some differences there, but it's not going to be the same. All right, so then volume of water applied and how often? Okay, so basically chemicals move from this area of high concentration inside the particle to an area of lower concentration, which is the water between the soil particles. And so if you water frequently, you're going to dilute the nutrients out of that space between the particles in the medium. And just the way chemicals work, the nutrients inside of the granules therefore may move out more quickly, just because they move from an area of a lot of nutrients to an area of not very many. But in the end, that may mean that your fertilizer doesn't last as long as you thought it was going to, because you essentially got it to move out more quickly by adding water. Now, the one that maybe didn't catch you, but you should, is the temperature of the medium, since chemical reactions are affected by temperature. And so here's a good example. We know that sugar dissolves much more quickly in hot tea than it does in iced tea. That's why when they make sweetened tea, they make it hot and then cool it down. They don't try adding the sugar to cold tea. So it shouldn't surprise us that the temperature of the medium and the water around it will affect the granules. And that may affect how quickly the nutrients inside become dissolved, and it may affect how quickly they move through the coating. So temperature plays a more important role than we might have thought, and it's probably not something we obviously thought of compared to the others. All right, so let's look at some of these factors separately and how we can deal with them. So the question, do I just sprinkle the granules on the top of the pot, or do I incorporate them in the medium? And a good example, this picture here, this is Osmocote, and they're sprinkling on top, and Osmocote will tell you to do that. Some of the others will advise that you stir the particles into the media or cover them with a small layer or something. So keep in mind, the nutrients can occur only where the granules of fertilizer are touching moisture. Generally, not much comes out otherwise. And so if the particles are only touching a little bit of soil and there's only a little bit of moisture there, the nutrients are mostly only going to move out through that spot, okay? Whereas if the particles are stirred into the medium, then they're going to get exposed to moisture all around them all the time. And so the stuff may move differently. Now, I have to make a disclaimer here. Osmocote is designed somewhat differently than some of the others. And at least in the formulations I'm aware of, the nutrients inside of it are already in a concentrated liquid. And so that makes Osmocote work somewhat differently than some of the other control release fertilizers, because the inside is in a little bit different situation. But anyway, whatever the manufacturer recommends, but you just want to be aware of that. So we know that leaving the granules on top of the pot exposes them to brighter light. That doesn't have much of an effect, but it would raise the temperature of them. It is possible that some nutrients can volatilize, which means they pass through the coating, but into the air. They don't necessarily pass through into water and you don't get them. And it may also mean that if they're warm and wet, the nutrients come out rather quickly, particularly if you water frequently, and you may lose a lot of nutrients. But it's best to read what the manufacturer suggests. So some people apply this, it's called top dressing. Other people, when they top dress on a crop, trying to finish it at the ends, don't really use control release granules so much as they use fertilizer that releases pretty quickly because they don't want it to hang around very long. So there's different theories on that. So how often do you water the crop? Well, how much do you apply? Well, of course, that's going to be crop specific. So the general practice in greenhouse horticulture is that you want to water the pot or whatever size container it is until the medium is completely saturated and you see some solution running out the bottom. And then we often don't water again for a few days so that we allow air to move back in and fill up some of the pore space and provide the roots with oxygen. But we don't want the medium to go dry, so we'll water it again. So we want to be aware that the control release fertilizer is releasing nutrients slowly into the water that's between the medium particles, or soil particles we want to, and that's where the plant roots, the root hairs, are going to uptake those. And so it can be problematic if you water a lot or you water several times. And there are crops that might require that, but normally that runs the risk in this case of washing out some of your nutrients into the runoff, to increasing the amount that's lost, the amount that runs into the groundwater. And it also washes out your money. So if you've got a crop that requires frequent watering, like twice a day or something like that, CRF may not be the best possible thing to do here. These may be better to be watered with dissolved fertilizer in the water once and then with clear water the next time. So you have to evaluate that, but just be sure that your system matches CRF well. So as I pointed out, the soil medium temperatures can affect the rate of release of nutrients. Who knew that? Who told you that? Well, probably you weren't listening because it wasn't told to you very loud. But the companies that make CRFs are generally aware that temperature has a substantial effect on the release of their products. And if you read the fine print and the little bitty things on the studies on the label, you find out that the CRF products have often been tested at a particular temperature for a particular amount of time with a particular amount of water applied. So all those things are controlled. And if the temperature and the volume of water and the time all match, then they'll release as advertised. So if it's a 90-day control release fertilizer, they'll test it and say, well, we tested it and the water of the medium was 75 degrees. And, the medium was saturated once a day or something, and this lasted this long. So the problem is you're probably not exactly on the same. So here's an example. So Osmocote 14-14-14 is a 3 to 4 month CRF because they realize that it releases at different speeds with different practices. Anyway, we know that Osmocote releases at the full rate, it's going to release at around 70 degrees or higher, and at higher, maybe even faster. And so it could release differently at other temperatures and under other conditions. Since I'm in Florida at this point, we can say that Osmocote is not widely used in Florida because we're often above 70 degrees all the time. And we discover that the Osmocote releases the nutrients too quickly. And so if we were planning on it for 90 days and instead after 30 or 45 days, it's gone. Right. So like in our examples, and I'll give you some experiments we did here, that we use a fertilizer from a local company called Diamond R. And they sell this 26.9 Nursery Advantage, and they claim it for 180 days. Well, if you read their information, they'll actually give you a chart showing their fertilizer release. It's rather a linear sort of thing. And it's tested at 86 degrees. Okay. So the question is, am I at 86 degrees? Is my medium, that temperature, and they don't really discuss water and how often you water or whatever. So they don't actually say, oh, well, we did that in pots or we did it in a lab or something. But we do know that this fertilizer releases at the expected rate at a higher temperature. So this is an example. So the question would be is, how do I measure nutrients coming out of the pot? Well, I guess you could look at it. That won't help much. I guess you could catch what's flowing out. That might help. Okay. So how do you measure the temperature of the soilless medium? How about a meat thermometer? Would that work for you? So we might try that. And if I've tried to match my fertilizer, my watering regime, do my plants look the same? Did they turn out just like I expected from last year? And well, not necessarily. That could all change. All right, so the nutrients out of the pot, the runoff of groundwater, our main concern is initially with total dissolved salts, TDS. And we're also concerned with how much nitrate, nitrogen, or nitrates. That's a arithmetic problem again. There's nitrate, nitrogen is about 20% of the nitrate. So how much is going into the runoff? How much am I losing? What should I expect to get the best results for my plants? Fortunately for us, checking TDS is inexpensive, it's routine, it's non-technical. So you'll need to purchase what's called an EC or TDS meter. These are on Amazon. Yeah, you can spend a lot of money, but $10 is about what I'd tell you to spend. And we use these frequently in class along with some more expensive versions just to prove to students that you don't have to spend a lot of money to get good results. There's no moving parts, there's a couple of batteries. It's not necessarily entirely waterproof. You have to be a little bit careful. If you can tell here, there's a line at the bottom. So about an inch or so goes into the sample to measure the TDS. And you don't want to hold the top part underwater. That's not good for the electronics. But anyway, we don't have to calibrate it. It comes pre-calibrated. You can buy a calibration solution and test to be sure it's reading correctly. And most of these little meters will tell you a way to calibrate it if they're not. It also tends to read the temperature, and that's very important for us because this measurement is highly variable based on temperature, and you need to know what temperature you're reading it at. So anyway, we just insert, so we can collect water. We use a couple of methods for collecting water the same way every time. That's fairly important to see how much total dissolved salts we have. And fortunately for us, there's published tables online. You can just Google in TDS temperature tables, and you can get a table that tells you how to, if it reads this amount at 25 degrees, then what does it read at 30? Okay, so you don't even have to worry about that. And so it's kind of handy. And so all I warn you is that with this sort of thing, you want to take 4 or 5 measurements and take the average. Never take just one. And we tell students to do that. And then we take more expensive meters because you can spend a lot of money if you want to. And we also do it the same way. And we often find that not only do the readings the same, but they're almost equally dependable. So, but sometimes, sometimes you should take 10 readings with this one, and the cheaper one you take 3 readings, but we like these fine. So we now have the total dissolved salts. Let's see what's going on here, how much nitrogen. So how does this work? How would I guess how much nitrogen I was losing? Well, there's a rough way to guess, and there's better ways to do it. So the rough way is if you know your fertilizer and you've measured your TDS, you can guess how much is in it. But you have to be real careful to eliminate the salt that's already in your tap water. Okay, you don't really care what that is except to remove it from the numbers. So in the example I give here, if we take the water from the pot and we get a TDS reading of 400 parts per million, and we've already measured tap water and it has a salt reading of 250 parts per million, and some people tell you that's high, but here in Florida, that's not high, that's really common. Then we know that the fertilizer is only the difference. So it's only about 150 parts per million. And the nitrogen in fertilizer is measured direct. So unlike phosphorus or potassium, which is not direct numbers. So we could say 20% of that 150 should be 30 parts per million should be how much the nitrogen is. Okay, that's a rough guess, but it's not terribly wrong in most cases. It could be different based on temperature, based on water volumes. And we use a thing called the pour-through method. I'll give you a reference here, just to record it. And again, Dr. Merhot does a lot of this work at Riverside, and this is a free publication. Hort Science is open access, and you can pull this up and understand how he's measuring that. And he looks at pH as well. And we might want to look at the pH in our pots because in our water, because it tells us how nutrients would be available. We generally want the pH of our medium in the high 6s for most crops. Some crops lower, azaleas need the 5s because they need acid, and some things need high, 7.5 because they need alkaline soil, but those are the exceptions. So, but I'm not going to talk much about pH because that's a different story here. So we're still looking at how much nitrogen is in it. So there's more accurate ways to do this. So if you follow that pour-through example, and the reason I tell you that is you can do it the same way every time. And so you can always compare your results. So that's why you want to do things the same way. All right, so you can get nitrogen test strips, and these are available on Amazon or your aquarium store, or your pool, maybe even your pool supply. They test for different things. And several of the companies have come up with a phone app that help you read it. And these strips just have little pieces of attached chemical, and you dip it in your sample and you wait a set amount of time and a color develops. And it turns out that this is an old system, and it's a pink color system. So we can get things like this. These are available. And as you can see on the side of the container, the strips look white, and you stick them into your sample, and then you can get 2 or 5 or 10 or 20 parts per million nitrate nitrogen or so forth. And this set has a fairly low reading number. Up here you can see it against a chart, and you just have to match, is the pink pinker than this or less pink than that. And so some people find it harder to read, other people find it pretty simple. And it's been recommended for a long time as a good guess of what's happening. So with some new systems, there's a phone app. You let your strip develop for about a minute. You put it next to the test thing. You use the camera on the phone, and the camera tells you what it is. And here's one. We've actually used this one. We use as a teaching thing. These come as an M-Quant. This is a German product. And it looks like 10, 25, 50, 100, 250 parts per million, but it has a card that we can scan, and it actually sorts between those. So it may have 15, it may have 30, it may have 40. It has a number of different color ranges, and we scan the phone, and the phone scans it, and then it tells us more precisely. In other words, it'll come up and say, this is about 75 parts per million, and we can't get that off of the card, but we can get it off the phone. So the phone apps are free. The strips vary in price from a few cents to, you can easily spend 50 cents or more per strip. We recommend some that are about 40 cents, but some with the phone app are a little bit pricier since the phone app's free. But anyway, these are out. So this is a good way to narrow that down. And you say, well, how do I know what I want? Okay, that's a little bit harder. There is a nice general rule of thumb. If you have over 30 parts per million nitrate nitrogen, it's probably excessive for most crops, and you're wasting it. It's going to pour out of your pot, and you're going to lose it in the groundwater. If you have less than 20 parts per million nitrogen, you may not have enough fertilizer for your crop, but you may. That's crop dependent. Certainly, if you're down around 10 parts per million, that may or may not be sufficient. It may slow your crop, or you may wind up with plants that look under fertilized. All right, so let's try something a little more technical. All right, so this gizmo here comes to us from a Japanese firm called Horiba. We've tested a lot of different nitrate meters. Some of them are very pricey. Some of them are hard to use or very finicky. They require very specific things. And some of them are not dependably repeatable, at least not not using students in regular greenhouse samples. Maybe they are for something else. Anyway, we spent a lot of time testing these. This one we finally decided we can recommend if you have the new version. Now, previously, when these came out, they were most commonly used for testing groundwater and ponds and runoff and stuff. And they didn't have a low range. If you didn't have 60 parts per million, at least nitrates in it, you wouldn't get very far. It wouldn't read it. But they've been able to improve the gizmo, and now we can read down quite a bit lower for both nitrate, nitrogen, and for just nitrates. And the machine will do both. You just toggle a switch, which one do I want? It doesn't require any reagents, and there's no reaction. There's a little area underneath the flap there where you put the reagent. You need about 0.5 milliliter, which is really a very small sample. And there's some calibration solutions that are a little bit pricey, but you don't have to worry about it too much. Now, my impression of the gizmo here is that it can be fidgety. Some days it doesn't seem like it wants to work. We change the batteries frequently. It uses two 2032 batteries. And we have discovered that it's really better to turn the machine off between measurements, even if it's only for 20 or 30 seconds. It all seems related to getting the batteries not only to last longer, but we get more dependable readings, and the machine seems happier than if we just leave it on endlessly. It is waterproof. You can throw it in the pond. It's handheld, and it does now nitrate nitrogen down to about 1 part per million, which is really good. So what does it cost? Well, I haven't seen it for sale for under about $350. The nice thing about it is it'll do about, claim 5,000 readings, and then you replace the sensor in the little white part, and you buy another one, it's about $100. So you don't have to replace the computer part ever, in theory. You can order a fancy one like this bottom. It comes with a kit with a case, and there's standards and a bunch of things for measuring, and this is their soil version. So you could use that. We don't have the kit, we've just got the meter. And there's a whole bunch of meters in this series. So there's a pH meter, there's an EC meter. You know, it costs $100 or so, and it does exactly what the $10 one does. There's one for calcium, which we're finding a little difficult to use. It's harder to calibrate than the nitrate one. There's one for potassium, we seem happy with. But anyway, I can recommend the nitrate one, having looked at several others. So that could be highly specific for you. So, so then how do we measure the temperature of the soilless medium? Okay, well, can't we just measure the greenhouse? Well, you'd think it would be easy, but until recently it wasn't. There weren't any devices designed to record the temperature of soilless medium in a greenhouse. I asked consultants at trade shows and stuff, if you're asked to come out and diagnose fertilizer and water problems in a greenhouse, how do you measure the temperature? And they all are prepared to do it, but they all use a meat thermometer. They stick it in a few pots, they write down the number, and they're done now. And that's fine, I guess, but I think you need more information than that. Now, there's a fair number of various temperature sensors that are mostly used in kitchens for food and for storage and for a variety of things. A lot of them are not particularly good for long-term in the greenhouse. We'd like something we'd leave in the pot. And then there's hardwired devices that are used for soil temperatures. These are big, expensive probes. They have a wire and they plug into a meter, and there's a lot of things going on with it, but they're not really designed for soilless media and for smaller pots. So what do? We do know that greenhouse temperature is not a good proxy. The temperature goes way up and way down much quicker in the air in the greenhouse than it does in the media. So here you go. Here's your soil probe. You can take this. This is your meat thermometer, and you can get quick readings. And these don't cost much. You can buy at the grocery store. So you can certainly start there. There's all sorts of these probes. Like I said, a lot of these are designed to put in refrigerators or to put in, not necessarily ovens, but in areas where they're checking things. Some are thermostats and various things. None of them are really designed for greenhouse for what we're doing. Here's a different one, maybe a little bit better, different design. And of course, you've seen one of these. You can just stick this in the pot and come back and read it. So what's wrong with that? Well, nothing. This is probably plastic and metal that won't rust, but it also probably doesn't keep a memory. So you would know the temperature right now, but you wouldn't know what it was 5 minutes ago or 10 minutes later. So you probably would like that information. So there's a company called Onset, and they've turned out a gizmo called a hobo. And we kind of laugh at the name. And if you read the Onset page, you'll discover that the hobo really was named after the old hobo on the trains. The founder of Onset was kind of a train fanatic. But anyway, they had a series of loggers, and a lot of people use them in greenhouses. They would hang them from a string or put them on the bench or whatever to collect light and fertilizer data. And I mean, light and temperature data. And the temperature data has also been used in a lot of other things. So a hobo has been put in, say, a box of cut flowers that are put on a truck to see if the truck stays the right temperature in transit. Did the truck get warm? Did the truck get cold? And so forth. And there's been lots of variations on this over the years for that kind of thing. And although they were waterproof, you had to take them near to a shuttle and to read the data. And there was no way to get it off of the old ones if you didn't have the shuttle, and back to fidgety. So the shuttle sometimes wouldn't connect right, and sometimes the data would be corrupted. You'd have to try to re-download it 4 or 5 times. And so there were some complications, and the shuttle had to be plugged into, sometimes into a computer to reset things on the data loggers. And so anyway, Onset turned out this new set, this MX2200 series. So they look a bit like this. They're small and kind of flat. This one's for reading just temperatures and could be used in a box in a refrigerator truck or anywhere you just want to record the temperature. This one has the light sensor. We tend to buy them that way in case we need it. It doesn't cost that much more to have the light sensor. You don't have to turn it on if you don't want to. And they come with the phone app that's free. So all of a sudden it looks easy and you say, wait, how does that work? Well, these new sensors, unlike the old ones, have a Bluetooth device, and you can set it to transmit. Now, admittedly, the batteries don't last as long if you transmit all the time. We get about a year from our batteries. But it means I can walk in the greenhouse, turn on my phone or my iPad that has the software, and immediately read the temperature for all the sensors that are turned on. I can see if one's not working correctly, if for some reason the battery's quit or it stopped reading, although normally we don't have much of a problem with it. We tend to start new batteries every year when we start an experiment, so we know they'll last for 6 months. But this allows me to do that. I can download the data and I can track it continuously. And so it's very, very useful to be able to come in and say, what is the temperature in the media? And the greenhouse got cold last night. What happened in the pots? Did it make much of a difference? And usually not much. Oh, it was hot yesterday in the greenhouse. The cooling system all came on. Did it make difference in the pots? Well, maybe for an hour or two. But the average temperature during the day and through the night was only, 1 degree different. Okay, well, that's good information because the fertilizer reacts with the water and the temperature, not the light. Anyway, these are inexpensive. I think the temperature one's about $50. The one with the lights maybe a little over $60, and the app is free. So that's good. So we like this quite a lot. So how we used it. So last year, this is an example. This will help you understand. We were conducting production trials with philodendron. This is philodendron imperial green, a patent variety. And we use systems like this to train undergraduates how to set up an experiment that has more than one variable. Because a lot of experiments are fairly easy to do if we only have to measure one thing, but that's never true for plants in the greenhouse. So for our experiment, we had 3 different rates of control release fertilizer stirred into the pots. This was based on recommendations that were made 30 or 40 years ago for foliage plants. So we picked 3 rates. We have 2 different light levels. The greenhouse has an old roof, so we can put plants, even foliage plants, on the bench without putting them in shade, but we can also shade some. So we have it set up with a structure that shades part of it and carefully doesn't shade the rest. And this, for those technically inclined, was a randomized block design, which means the various treatments were scrambled within each block. There was 3 blocks within each set, and there were 12 replicates for each treatment. So in the end, that means we took the average of 12 pots that had the same treatment that were distributed throughout the experiment, so that we took out factors like all of one type of one ray of fertilizers on the outside edge, does that make a difference for irrigation? Does it make a difference for temperature? And so just sort of mixed up. So anyway, so we took these and we buried 3 of them in the pots that were in full sun, and we buried 3 more of them in pots in partial shade so we could track it. And some of the pots had plants, and we also had some pots where they didn't have any plants, just the fertilizer and whatever. We wanted to see if there was any difference between plants, pots with plants and pots without plants. We didn't expect any, and this is a small sample, so we didn't see any. So anyway, we tracked the temperature over 6 months. We downloaded it. We measured. We had the sensors read the temperature every 30 minutes. We thought that was often enough. And after we averaged it together, we discovered that over the entire 6-month period, the average medium in the sun was about 1.5 degrees Fahrenheit warmer than the average soilless medium in the shade structure. Now, so that means the roots were just a little bit cooler, not very much, a little bit cooler. Both were in the 70s Fahrenheit, so we weren't up in the 80s where the formulation had been set to release. They were all in the same watering zone, and although there's a 5 or 10% error in our sprinklers, they were all watered at the same amount of time with essentially the same volume. So we removed the water as a variable. We wanted it to be the same. All right, so what we did was we didn't get all the data we wanted. Of course, the pandemic caused some of the student collected data not to happen, but we were able to collect total dissolved salts from samples and measure it. And so it turned out that at 150 days, we were getting essentially no fertilizer in the irrigation water for any of the crop in full sun. Now, we would have measured it more frequently if it had students. There was still fertilizer at 120 days. And so we know that somewhere between 4 months and 5 months, that 180-day fertilizer got exhausted in the warmer treatment. We also know that at 150 days, most of the pots in the shade, I won't say everyone had a high amount, but all of the pots in the shade had some salts left that was still coming out of the fertilizer, although it was clearly getting toward the end of it, okay? So we couldn't tell any difference. The high fertilizer rate either ran out or didn't as quickly as the low rate, okay? So, so sure, we are getting different amounts in the pots based on how much we started with, but we just noticed that. So we couldn't figure out any reason other than lower temperature that the CRFs would have released more slowly the nutrients in the shade-grown plants. Light has no effect on fertilizer, and the water was the same. So it seemed, and the plants were tissue culture clones. We didn't see any difference there. And so, how did our plants look? Okay, so I'm trying different fertilizer rates. I'm trying different light levels. Are my plants all the same? Okay. And so in this case, the crop did look different when produced under different light levels. And we would expect that with foliage plants, particularly those that are a little sensitive to light, although philodendrons often can be grown in the landscape as well as inside, so they can do both. So the generally rule across all the fertilizer rates was that the plants in the full sun grew a bit larger. They grew a bit faster. We could tell they were, if I were doing a production schedule, they were a week or two ahead of the others. But they also appeared to be somewhat yellowy green or chlorotic. Now, not chlorotic as in diseased chlorotic, but just not as green as I might have expected for that variety. And the plants in the partial shade were a little bit smaller, not significantly smaller, okay, when they became saleable. Now, they may have been a week or two to catch up. So in other words, the production schedule would have been a little different. And if I'm selling plants on a production schedule, I'm concerned about that. But they were smaller, but at 150 days, they were saleable. Okay, the two were both saleable. And the ones in the shade were darker green. Okay, not surprising. They still had fertilizer and they had somewhat lower light. Sometimes we don't associate lower light with darker green leaves. And so we think we associate it with the fact that there was still enough fertilizer left, okay? So how do we measure that? Well, we use a thing called a colorimeter, okay? And we use these to measure how green our plants are, and you can do this too. And so we put the colorimeter, I'll show you in a couple of minutes what that looks like, but we put the colorimeter onto the plant leaves and we measure the color green. And then we can actually look up in the patent the color green that's described for Philodendron Imperial Green. And it sounds sort of technical, but there's a reading we can measure the color between the two. And so our plants in full shade, I mean, grown in the shade, were essentially the same green color as the plant described in the patent. So we were exactly the color that the person who owned the patent expected Imperial Green to be. It doesn't sound technical, but it is. The plants in the sun were paler green, and the numbers caused for a relatively large difference from the colorimeters. And the technical description actually is that anyone could tell they were not the same color at a glance. You wouldn't have to study it at all. Now, we felt in the end, we usually conduct a buyer survey. So we also have students do a buyer thing and we get to grade plants on quality and consumer acceptance, but we couldn't do that with the pandemic. But we felt in the end that these plants were equally marketable because philodendrons are available to the consumer with different colors all the time. And some people may simply prefer the other color. Otherwise, philodendrons that were other colors wouldn't sell, but they do. Right, so what if I want a colorimeter? Okay, well, colorimeters are widely available now. They've become very popular the last few years with all this do-it-yourself home renovation stuff. And you see people selling them so they can match the color of the sofa with the color of the wall, with the color of the carpet. And they can. And therefore, that has driven the price of colorimeters down. There's several under $150. They all operate with a phone app. They have almost no moving parts, and they can read colors and compare them. Some of them are better than others. You can read the review online. Now, we also measure chlorophyll in the leaves using spectrophotometers. These tend to be much more expensive. Common SPAD meter we often hear referred to is $3,000 or more. And you can spend quite a bit of money on getting kind of upscale ones. And we've got several spectrophotometers. And so we've taken the time actually to measure the chlorophyll in the leaves and then compare that to the green color that the colorimeter tells us. And we can tell you what full green is, but you don't need to do that. There are some researchers that have published readings using colorimeters saying that they could actually determine if a crop was making maximum use of the nitrogen and that more nitrogen would not have made it any greener. And that's good news to know. In our experiment, we felt like in the end that the lowest fertilizer rate turned out just as good a quality crop as the high rate and didn't waste near as much fertilizer and didn't waste near as much money. And so we could recommend for Philodendron Imperial Green the lower of the three fertilizer rates tried. Someone could try lower. We don't know. We didn't do that experiment. So if we look at the color sensors, so this one is NYX Pro. It's a little black octagon. We've had it for several years. We like it quite a lot. It reads the colors, and we can match the colors against the World Horticulture colors that some of you may be familiar with that are used to describe any patented plant and lots of other things. And so, and we use this for a lot of things. We actually measure fruit juice color. We can do that because the way it's arranged, we can set it actually on top of a thin layer of fruit juice and measure the color, and it doesn't foul up the colorimeter or do anything to it. So kind of unusual. So this one, the color Muse, is another one we use. It's the NYX Pro, I think is $250–300. Has some really impressive software. The Color Muse has a more expensive version, but we wanted one that would read very small bits of color. And the Color Muse will read color swatches that are 4 millimeters. which is very, very small. And we couldn't find any other colorimeter that would read anything smaller than that, except for a few that were imported for, again, thousands of dollars maybe. And we use Max, and the others didn't have any Max software either. So we wanted things that we could operate just on our phone or our iPads. And so here again, this has a phone app, and you just set it down and you click scan, and it gives you the data. So it gives you information about the color, and you can compare it to things. And so we find this really useful in the greenhouse, just to compare if our plants are similar. It's very simple to use. We can do a plant in just a few seconds, actually. Are we getting the same color? And we can take several readings. The Nix Pro software allows us to take 5 readings and average it. So that's really good. And so this is kind of good use if we use this with our controlled release fertilizer systems, and then we can see if our plants are all the same or if they're actually different. And sometimes they aren't the same green, and sometimes it matters, and sometimes consumers don't care. But again, keeping in mind, we're trying to find useful information, but also teach students how to measure different sorts of things to see, in fact, were there differences in their experiment. And so that's what we use this for. So with that, I think we can take some questions. So far, we don't seem inundated.
I'm still looking, John. Yeah. One thing you've challenged me to do is to get out there and my future workshops emphasize just how cheaply some of this technology has gotten, save the growers money, and also, mitigate pollution one fell swoop. That's a no-brainer. So I love that. And some of the stuff you showed today is much cheaper than I realized because I haven't played with it. So I personally thank you. And then also I want to get your YouTube posted to our Oklahoma Nursery Landscape Association site, just simply because we have growers that are clearly busy today and didn't tune in, but I want them to tune in around their schedules and learn from you, John. So this was fantastic.
A lot of it's very affordable. And so as I said, while we're training students, we actually train them that when they go to discuss this, if it's a poster or they're going to a meeting, we say, okay, in the conclusions, let's discuss if it's affordable and if it's easy to do, and if the stuff is repeatable, not just by no research results, but how useful could this be? And so I would encourage them particularly to get a TDS meter, because they're so inexpensive and they can tell real quickly if their water, if their regular tap water doesn't have much salt and the stuff coming out of the pots has lots, and they know they're losing a lot. And they can be sure that some of it's nitrogen. So they should know that.
Absolutely. Well, that's excellent. Is your average grower in Florida adopting this technology, particularly now that you can show them just how affordable it is, or is it pulling teeth for some people? Or I'm just curious.
Well, there's been some nicer publications, and I think what they have been relying on a little bit was for the extension folks to publish generalized recommendations, because that's been done for a long time. But as we get new varieties, the extension folks can't really stay up with it that way. It's very hard. Mm-hmm. And so, like this year, we're doing a different philodendron, but we're doing a new variety called Birkin, which just released last year and has come out of all the tissue culture labs. It's kind of the biggest thing going, and so we were able to get some plugs. But there's no written recommendations at all. So, but I think the growers are concerned substantially about groundwater contamination and retaining nutrients, because the Florida law requires containerized nurseries to retain all their water.
Okay.
And so if you've got a retention pond and you're pumping, water around into it, you need to know if that's full of nitrates and or full of other chemicals, and what do I need to do to clean that up. And so I think the nurseries have been paying a fair amount of attention to that for quite a long time, and that's a good thing.
Sure. Gotcha. Excellent. Donna, can you help me look at the chat feature? I've lost that on my screen. I want to make sure I'm not overlooking any questions for Dr. Griffiths. Do you see any that I'm not seeing?
No, I'm not seeing any right now.
Okay, thank you. I want to make sure I wasn't ignoring him.
All gone to sleep.
No, they're interested. They're just like me. They're thinking through some of this, probably some of these techniques and tools that perhaps we haven't all used to the extent that we should be here in Oklahoma. And I'm certainly guilty, and I'm taking notes, and I will definitely be reviewing this YouTube or this recording 2 or 3 times just to get up to snuff on some things that I'm behind on. So one of the many reasons I selfishly brought you aboard today. Random, go ahead, please.
Nitrate strips that have the phone app, because the hit on those previously was that they were just too imprecise. And I've actually had a student we've been working this year with a student in the lab we've taken standards from essentially 1 part per million to 200, 250 parts per million nitrates, and use different strips. And we've used the colorimeter to take multiple readings to give us the color. And so I like the new ones with the phone apps. We think that they could be better, but we know that environmental people that are running out to test runoff and test pond waters and things looking for chemicals are using those, because the phone apps are much better than the old eyeball technique. So I would certainly recommend someone consider getting those. They have a shelf life, so want to be careful. The strips are often only good for a year, and don't put them in a hot place. Put them somewhere where you take care of them. But the fact that you can just put that down with a little card and your phone can tell you what it is a huge improvement, and it won't cost you very much to do it. So I think that's a very valuable thing that should increase in use substantially.
Yeah, this is so exciting. I'm looking here. I took down a couple of notes that I haven't already asked you. John, while I'm thinking on this, this is random, but again, I was sincere. I do want to get you up for another purpose, and that's some of our global horticulture undertakings as well. So when you're working in countries that maybe in some of them aren't quite as financially blessed, so to speak, as the United States in some cases, I guess some of this technology, though, just off the top of my head, would still be very applicable, even if people maybe didn't have the means that some of your growers in Florida do, or are you incorporating some of this? I know you're in East Timor, so to speak, this week. What are your thoughts on that? Because I don't know what's going on globally in this respect. I've never done a workshop in nutrition.
Well, because the TDS and pH meters, those little handheld ones, are so inexpensive, and the trick to using those really is to understand that first off, I have to take several readings, and what it can't do for me. But I recommend people do it. I discover that a lot of times in an international project, I'll get a rather lengthy song and dance about this and that and this and that. And I get there and I say, has anyone measured the pH of the well water? And they all look at me like, what?
Mm-hmm. Okay.
Over there, and we measure the pH of the well water, and it's 7.5. And I look at it and I go, okay, we've answered your problem. And they go, what? And I said, your water's too alkaline for what you're doing.
Yeah.
Tying up your nutrients, and we've got to address that. In other words, all the things they thought was haywire and was wrong, it wasn't. They were applying the right amount, but because their water was not the right pH, it wasn't working.
Yeah. Gotcha.
And I've discovered also that most people are always concerned about nitrogen. Do I have enough nitrogen? And they don't realize the biggest limiting factor in almost plant growth in every situation I know of is calcium, not nitrogen.
Okay.
And so if you don't have quite enough calcium, I can give you a good example. If I'm growing poinsettias, I get a very fine brown edge around the red bracts, and I can't sell them because the cells didn't expand correctly and they died. It'll cause the leaf to cup up.
Mm.
So I know I have to apply calcium as a spray to poinsettias to be sure that I don't have that problem. But if you think of growing tomatoes or peppers, what's the number one nutritional problem? Okay, it's blossom end rot. Well, that's because it didn't have enough calcium. It had nothing to do with pests or diseases or any of those things. We didn't get the calcium to the right place in the plant at the right time. So And if we get funny distorted seedlings, it says, why are the leaves cupped? Why are my leaves cupped? Okay, well, is the light too bright? No. They didn't have the right amount of calcium because they were forming, and those cells at the edge didn't expand. And I can't later. So,
Interesting.
and a lot of that has to do with pH. Calcium is the annoyance, and hydroponics, the calcium nutrient's the one you have to add separately because it causes problems with the others. So,
Yep.
So when I go overseas, I usually take and I give away TDS meters. I take pH meters, the inexpensive ones. I have taken sometimes those strips, nitrate strips, just to use the test because they're not expensive. And I mean, you can buy them at the aquarium store. Those aren't quite as good as the ones just for nitrate, but they're okay.
Mm-hmm.
They're you take what you have available, I think. I mean, as we turn out things, we'll say, well, the ones just for nitrates, we trust them a little better, and there's a little quality control in the aquarium strips, but a lot better than not knowing anything. So.
And we all have the time to repeat those ones that are less expensive. We can justify it because of how cheap they are. That made sense where you say you might do 8 to 10 runs and then take X bar of the average. That makes a lot of sense to me. You're still way ahead, even with your time, because you can probably do that quite rapidly. But yet say,
yes, and it only takes 5 or 10 seconds, so I can set that down, take it out, shake it off, put it in again. When it's in contact with the water, will give me a reading, and the second I take it out, the conductivity is broken and it goes to 0. It's a very simple thing to use.
Yeah.
Moving.
Yeah. So very, very easy to convince people why it behooves them not to have to go for the Cadillac version right off the bat. Gotcha. That's fantastic. Donna, can you see anything else in the chat feature? I'm sorry that I'm frozen here for some reason today. I want to make sure I'm not ignoring any of the participants.
No, there's not anything.
Okay. John, this has been excellent today. Like I said, I'm going to make sure this gets posted to our main grower website, so to speak, so people can look at this at their leisure. Hopefully they will at some point in time. I wouldn't be surprised if they, or certainly me, as I digest more of what you said today, come back with more thoughts and questions with you or to you in the future. But we're grateful for your expertise today, and again, look forward to getting you up here physically sometime to Stillwater to further educate us. But I think if there are no more questions, we might go ahead and let you go back to East Timor today, so to speak.
Actually, tonight is the monthly dinner for the local chapter of the Florida Nursery Growers and Landscapers Association, and I don't always get to go, but I could go tonight, so that's kind of nice. So,
okay.
See what they have to say, but they didn't ask me to talk, fortunately.
Yeah, you can just show up, no pressure. I love that. Those are my best ones, when I can just show up. Absolutely. So, listen, thank you again for your time. I just wanted to thank Dr. Griffiths, because when I first hired him, he wasn't sure if he was going to physically be overseas or not, yet he was still willing to deliver this at some obscene time of the morning or evening. I can't remember without doing the math, but so thank you, John, for that willingness. And it just worked out today, only an hour time difference. So we're grateful and I personally look forward to seeing you later this year at meetings, and for everybody else, hopefully seeing you when we fly you up at some point in time. So I think at this point, we'll go ahead and conclude, and look forward to seeing everybody back in December with TLC Oklahoma City folks speaking, Bob Gertis specifically speaking on industry challenges. And then at that point, we'll take holiday break and we'll jump into an exciting 12-part series for 2022. So we hope to see you all in the next few weeks. Be careful. Happy Thanksgiving, and we'll talk soon, okay?
Thank you, John.
Thank you. Thank you, guys. Thank you, John. Bye-bye. Thank you, everybody.